so basically all you do is you put both hands out here like this. You're going to put one hand round the front and one round the back, and your hips go in the opposite direction. You then reverse, both hands round the front, and repeat. And the faster you do it, the more awesome you look.
Mr. Ray, aren't they wanting to know about the force, not the floss?
I thought that you said... Right, can we just cut that? I've got a level with you guys. The force doesn't actually exist. But in the films, it does a lot of the same things that forces do. For instance, forces can change the shape of an object, like when you see someone's neck getting crushed by one of the evil guys in the film. They can also change the speed or direction of objects, like when you see things getting flung around the place in the films. In a nutshell, forces can cause objects to accelerate. Now, a mildly famous physicist by the name of Isaac Newton formulated 3 laws to do with forces. Newton's first law is about balanced forces, and it states that if balanced forces act on an object, then that object will either remain stationary or will move at a constant speed in a straight line. Essentially, the object will just keep doing whatever it was doing to begin with. To demonstrate that, I have an air track here. Along the length of this tube, there are very, very small holes, and air jets will be coming out of those holes. This cart will then float on a layer of air, on a nearly frictionless surface. And you should see that this object will move at a constant speed in a straight line because balanced forces are acting on it. Now my question to you is, what are all of the forces acting on that as soon as it leaves my hand? Well, if you said weight, then you're absolutely right. This is in a gravitational field, and therefore there is a force that we call weight pulling it downwards. If you said reaction force or air pressure pushing it up, you're right again, okay? There has to be another force acting up to balance the weight. Otherwise, this would just crash right to the centre of the Earth. If you said that there has to be a forward force, like momentum, pushing it forward the whole time, this is for you. Bad brain, naughty brain, stop thinking that. There does not have to be a force pushing things forward just because they are moving forward. Let me give you an example. Say you decide to take your bike to school. If there was a force that just magically kept on pushing you forward all the time, just because you were moving forward, you could push off from home and freewheel uphill, downhill, through traffic, all the way to school, without pedaling. Now, whilst that would be completely awesome, it would also be physically impossible. So there must be another explanation, and that is that just because you are moving forward, there is not necessarily a force pushing you forward. That is actually the whole reason why, if you don't pedal your bike, you will slow down. Because when you're moving forwards and not pedaling, the only force acting on you is friction slowing you down. Okay? So just be really careful there. So balanced forces, and the forces in this case vertically are balanced, which means it doesn't go higher or lower. And horizontally, the forces are also balanced because, well, actually there's no force pushing it forward, like we just said, and there's basically no force acting against it because it's on a near frictionless surface. Balanced forces cause objects to remain stationary or move at a constant speed in a straight line. At least that happens right up until the time where it hits these elastic bands. At that point, we now are looking at Newton's second law. Because Newton's second law states that if an unbalanced force acts on an object, then that object will either change its speed or change its direction. Effectively, unbalanced forces cause objects to accelerate. Now, to show you this in a bit more detail, I'm going to let you have a look at my private jet. And there she is in all her glory. So this jet, or aeroplane, is right now there's a force from the propeller that is forcing that plane forward. But there's also air resistance acting against it. But right now the force from the engine or the propeller is bigger than air resistance, and that creates an unbalanced force, which is why this plane is gradually getting faster and faster and faster. Now at a certain point, the force from the propeller and the force from air resistance will balance, and it won't be getting faster anymore. Now does that mean that there are no unbalanced forces acting on this right now because it's not getting faster? No. Bet you weren't expecting that. Yes, this might not be getting any faster now, but it is changing something else. It's changing its direction. There is an unbalanced force acting on this the whole time due to the string that is holding it to the ceiling. And that string right now is pulling it constantly towards the centre of this little circle, causing it to change its direction. So unbalanced forces cause a change in speed, but also can cause a change in direction. Here we go. It's okay. Now, there is a third and final law. Newton's third law. Newton's third law states that every action force has an equal and opposite reaction force. And to demonstrate that more clearly, here is a video of me getting a ball thrown at the side of my head. Okay, let's see how that relates to Newton's third law. The ball comes in from this direction, and the ball exerts a force on my head, okay, causing my head to move a little bit this way. But at the same time, there is an equal and opposite force from my head back on the ball, which is why the ball moved off in that direction. Now those two forces are equal. The only reason that my head didn't move as quickly as the ball is, well, partly because it's attached to my body, but also because it's more massive than the ball. And more massive things are harder to move. Okay? Now please don't confuse Newton's third law, every action has an equal and opposite reaction, with balanced forces. Balanced forces apply when the two forces are acting on the same object. Right? Like this. One force, two force. Same object. Newton's third law are where two forces are acting, but on different objects. Ball exerts force on head, head exerts force back on the ball. Okay? Just for a laugh, here is a video of me getting hit in the head with a ball in slow motion. So I hope you enjoyed that. Just make sure that you force yourself to learn this stuff and you will really accelerate through the topic. Okay, I think we got it there. Can you just really make sure to cut that awkward flossing bit out at the start?
Yeah, sure.